We are Innovate Driving, a web application that uses machine learning to make driving safer by predicting crash hotspots, crash severities, and detecting distracted drivers. In 2019, the United States alone had 7 million crashes, 38,000 deaths, and 4.4 million injured. These figures indicate that this is a very important problem in our modern world. Thus, we built an app to combat these issues. Our web application has three main features: an accident predictor heat map, an accident severity predictor, and a distracted driver detector. Let's get started with our heat map. A user can select a location, and from there, a heat map of the area will be rendered. We train our model on specific urban areas with data which contains road infrastructure, weather, speed limits, traffic conditions, and many other features which can affect accidents. As you can see, the heat map has red dots and severe hotspots, and we're able to do this with a neural network. Crash hotspots are important because they suggest there is a constant factor that results in more crashes than other locations. This alerts drivers to avoid certain locations, which ultimately saves lives. Now, let's go to our accident severity predictor. A user can input the location and time of an accident, and our model will output the predicted severity of the accident on a scale of 0 to 4. Our predictor is a random forest classifier and has been trained on tens of thousands of crashes. We can enter example data here, and the model outputs that if an accident were to happen in this location and time, it would be a stage 2. Being able to predict the severity of an accident allows city planners to create more signs notifying drivers of locations and times that have the highest risk of severe accident. Additionally, if first responders know the severity of an accident beforehand, they can prepare better to help those in need. Accident severity prediction is vital to the accident management process, as with this information, they can create more effective measures to reduce the severity of crashes and improve traffic safety. Next, we have our distracted driver detector. Distracted driving is the cause of 3,000 deaths every year. From an image of drivers in cars, our CNN model is able to detect what the driver is doing. Our model classifies a driver as either attentive or distracted. We are able to split our distracted drivers into 4 different categories, using the phone, the radio, the mirror, and eating or drinking. We can enter a picture and the model says that the driver is distracted and is eating or drinking. If we open up the photo, we can see that exactly the case. Although the model is fully functional, the feature is more proof of concept, as we would need live feed from a camera in a car. We plan on working with car manufacturers so we can link our model with live cameras and implement an alert system which alerts drivers who are distracted, allowing us to save countless lives. Lastly, we have our data visualizations. These are visuals that we use throughout our process of creating models and can also help drivers and city planners get a better understanding of road accidents and their correlations.